wanted to announce it earlier, but I haven't. Oh. Okay, so there's the F-sharp tutorials coming up, as you probably all heard about. Oh, look who's here. And so the F-sharp tutorials, really awesome. Miguel Diacaza, Don Syme, myself, Tomas, who's back there, a bunch of other really cool people. All, oh yeah, Dimitri's going to be there. And we're all going to be, there's going to be a 2-track event where half the group is going to be doing like beginner stuff because they don't know F-sharp already. And so it's a really great like 2-day bootstrap, start learning F-sharp event. And then for experts, there's a 2-day sort of like learn about crazy things like compiler internals and quotations and machine learning stuff. There's machine learning on both tracks, but it's looking like it's going to be really great. We're actually having a raffle tonight. So if you could take your little card and put it in that paper bag. I know it's a plastic bag. I know it's not looking cool, but if you are drawn, then you will get a free ticket to the F-sharp tutorials. There's also, I found out about today, about 2 new events. There's an F-sharp in finance event on October 21st. It's F-sharp like spelled out, S-H-I-R-P in finance.com. And there's going to be a machine learning and finance event. They're both being run by the same guy, but they both look pretty exciting if you're into finance stuff. So yeah, I guess just wait until your we've started with the actual machine learning stuff to come up. But other than that, I'll hand it over to Mathias.
How are you guys doing tonight? That's a slow response. Let me try again. How are you guys doing tonight?
Woo! Yeah!
Cool. So tonight we do a...
We don't have our exercise yet.
That's right. So tonight we'll do something which is not exactly a talk, it's really a coding dojo, so which means I will be working 10 minutes and you will be working for 1 hour and a half. Hopefully you will find the 1 hour and a half beneficial and learn something in the process. And the title of the thing is A Gentle Introduction to Machine Learning with F-sharp. So me, my name is Mathias Brandewinder. You can find me on Twitter @Brandewinder. I'm actually not a software engineer. My background is in economics, operations, research, all that type of stuff. 10 years ago, I fell into .NET because I found out that Excel was maybe not quite what I needed for, was not the right tool for the job. So I did some C# for a while, and in 2010, I saw there was a language shipping with Visual Studio. I read that you should learn a new language every year, so I thought, why not this one? And since then, I never looked back. I'm from San Francisco. I run the .NET group, the F-sharp group over there. If you come to San Francisco and want to fix a F-sharp, check out sfsharp.org, that's us. I do have an accent, and the reason I'm saying this is, like, first, it's a great accent, and second, it's sometimes difficult to understand, and also I tend to be quite excitable, so I speak faster and faster when I'm excited, which makes me harder and harder to understand. So the point here is, like, if you stop understanding anything I'm saying, like, please wave hands and stop me. If you have questions, stop me anytime. Deal? Yeah. Deal. I have a blog too, which is great, the company switzerland.com blog. So why am I here today? So this is actually part of a tour, the Summer F-sharp tour. What happened was 3 months ago, I did the dojo in San Francisco, and somebody in Carolina called me, I think it was from Raleigh, and they said, hey, it would be nice if you could come, and I said, sure, I will come. And then somebody else in Charlotte, I think that's here, told, hey, if you're in Raleigh, you might as well come as well. And so I thought, okay, I'll do it. And then it's like by linear interpolation, I noticed that people somewhere in the line, I knew people here, I knew Rick in New York. And so I thought, at that point, I look back and I'm not quite sure how committed to this, but like, I have been given, I think, 10 talks in the past 2 weeks, and I'm giving 4 more in the next days, and it has been lots of fun. And so I'm super excited to be in New York. It's kind of the fireworks of this trip. Thanks to you guys for having me, for Rick Azoras or Rick for having me, and thanks for being there tonight. So I just want to check something to get a sense of who is in the room today. Who has written F-sharp code in the past month? That's great. Who has written F-sharp code, period? Okay. Who has never, yeah, that's it should be, I didn't respond yes to the previous one, but and who has never written F-sharp before? Okay, that's cool. That would be interesting. yeah, so now you know everything about progressive F-sharp tutorials. Like, there will be a raffle, and you should absolutely attend because it will be awesome. So the goal tonight is this. Do you guys know Kaggle.com? Okay, so for those of you who don't, Kaggle.com is a startup in San Francisco. Their tagline was data science as a sport. So what they did was something like this. You're a company, you have data, you don't have data scientists, you don't know what to do with it. You give it to Kaggle, they make it into a cleaner data set, they make a competition, and you submit the results of your model, and the best model wins. So you're ranked, and it goes from you do it for kicks because the reputation is great, to you can make up, there was a competition with $2 million, I think, by GE 1 year ago, so you can make it for the money or for the reputation. And so tonight what we'll do is that we take one of these contests, which is one I participated in, and the goal is one, to write some code together, so that's what you guys are going to be doing, have fun doing it. Specifically, we're going to write a classifier from zero, no libraries, no frameworks, no nothing, because that would not be fun, using F-sharp, and hopefully learn some machine learning concepts along the way. Stretch goal, so that may be tight, but maybe people will even be able to send results to the competition and see how they're doing. That's a stretch goal. So, what you may need to know to do this. The contest we're going to do today is the Kaggle Digit Recognizer contest. You can find all of it on Kaggle.com and all of that. So what this is essentially an OCR system. What we have is a data set of handwritten digits. They ask people to take a sheet of paper, write a 1, write a 7, write a 2, write a 5, put it in a scanner, and keep that installed somewhere. So what they have is 50,000 examples of numbers which have been written by humans. And your goal in the contest is to predict 20,000 unknown numbers. And the rating of the competition is like the more you predict, the better you are. And our goal today will be to build a function or a code which actually does this automatically. So to be explicit, I hope it's not insultingly simple, I have also pictures. So the data we're going to deal with is something like this. Somebody wrote a 5, it has been digitized, and now I have pixels. I have pixels which are black, pixels which are white, light gray, dark gray, and so on and so forth. That is the material we deal with. The real data is a bit bigger than what I have shown. It's each picture is 28 by 28 pixels. Each pixel is encoded grayscale, meaning going from 0 to 255. Each record is flattened, so you can't really score a square, so it's like it's flattened on one line. And each line is like, what is the number? And then you have like 28 by 28 is 784 pixels, which is quite a decent number of columns. And that's a CSV file. So in pictures again, because pictures are beautiful. Here, suppose I have a 1, which is like that. The process would be take that guy here, slice it, slice it, slice it, and so on and so forth. And then put that guy here, and you get a flat line. And that flat line is saying this is a 1, and here are all the pixels you have. Everybody clear so far? You guys are very quiet. So I said we're going to write a classifier. So what is a classifier, you might ask? A classifier in English would be something like, if you give me an unknown data point, in that case an image, I will predict what class it belongs to. Class, implying classifier, that's where it's coming from. So in that case, the classes or the labels are going to be 0, 1, 2, and so on and so forth. So our classifier takes an image, gives us a number between 0 and 9. And yeah, that's what we're going to do. I picked for you the classifier we're going to do, and so it's a classic. It's called the KNN classifier. KNN stands for K nearest neighbors, and so in English, or kind of in easy form, given an unknown object to classify, in that case an image, the algorithm will look up at all the training examples I have. I will find the K closest examples, or the K things which look the most like the thing you gave me. For instance, if it was a 3 nearest neighbor, I would pick like 3 images which are the closest. The first one is a 1, the second one is a 2, and the third is a 1. I will take a majority vote. I have mostly 1, so I will tell you this. I think this is a 1. That's how the algorithm works. In images again, the dumbest, so much simplified. If we had like one training set which doesn't contain 50,000 items but just 2, I have an image for a 1 and an image for a 0, and my problem is I'm trying to classify that guy here, which is an unknown. So what I'm going to do is this. I'm going to look One way I could compare how similar or dissimilar things are is I compare them pixel by pixel. So we compare this to this, this to this, this to this, and I would get a map. And on this guy, I would see like I have a difference here at that one pixel. And so if I compute the difference and square it, I would get something like 255 squared. If I do this for this guy, if I compare pixel by pixel again, now I'm going to get like tons of differences. And so if I start summing up the differences, I'm going to get 255 squared plus, so I'm getting a number which is much, much bigger. And so if you look at this, like the distance, that number is much smaller for this guy than for this guy. So that's the same image, but like flattened a bit, like on the flat version of it. So here I took a distance which is, you probably have seen in high school, which is like Euclidean distance. You could use another one if you want. You could use, yes?
Don't you have to do any pre-processing, such as contrast enhancement?
You're a lucky fellow because you're getting a data set which is already clean and all of this. So I did I didn't actually tackle, did lots of painful part for you.
Okay.
And you could do, but you could still do things to the image afterwards. What we're going to do, pretty much what we'll do today is like what I did in the first hour in this contest. But then I spent 2 more weeks refining and do things like the things you described. Like especially you're rarely done with a classifier, so you can have like lots of smart ideas afterwards. So yeah, we're going to use that distance. So in the end is that we computed the differences. So I looked at these two guys. The distance between this and this is much smaller than between this and this. Therefore, I'm going to eliminate this one and just keep this. This is the closest, so I'm going to say, hey, this is probably a 1, and that's what my classifier gives you. Clear?
Yep. Yep.
Maybe you should ask, not clear. Okay, so I think that is really clear. Questions? No question. Good. Then what we're going to do is, as I said, that's pretty much it. So at that point, it will be your job, and you will be implementing like the classifier. So I think part of the fun is to also work as groups, learn from what others people do and stuff like that. So what we do is like we do roughly this. I'll create groups now. You guys will work for maybe 1 hour and a half, something like that. We'll see where we are, and at the end we'll share. So either every group or some of the groups will just share with the others what worked, what didn't work, what great ideas they had, what terrible ideas they had, and all that stuff. So how many? We're about like 25, so I will break it into 5 groups, and what I will do is this. So we'll do it, we count from 1 to 5, 1 to 5, like 1 to 5 modulo 5. So you will say 1, you will say 2, you will say 3, 4, 5, and then 1, and so on and so forth, and you will remember the number you say. Here? Can you start, Dimitri?
1,
3,
4, 5.
I'm not going to be staying,
Cool.
so it'll be 1. 1,
I pass.
I won't be staying.
2,
5.
1,
2.
3, 4. Wow.
Who's next?
2, 3, 4, 5. 1.
Cool. So like now, I'll let you guess the next step will be all the 1s will be together, all the 2s will be together, all the 3s will be together. We'll have 5 teams of 5. So at that point, what I would like you guys to do is that we have 5 tables, 1, 2, 3 here, 4, 5. Get around the tables with your team, set up your laptop, and we'll start working.
3, come on! We have to wait.
Seemed to run correctly, and then we ran it against the validation set, and it turned out we got 100% result, like everything was perfectly matched up. So then we found out like what was going wrong was that it's not a good idea to use the same set for validation. So we just put in the correct file path for reading the correct file, and we got the result 5.6, 28 out of 500, so 5.6% incorrect results.
Nice.
So 94.44% correct results.
Awesome.
I mean, I just want to say one quick thing. I mean, I think both Hong and I were pretty happy that we were able to write the classifier in 1 line, and it is a 1-liner. It's just like shows the expressiveness of that chart, I guess.
100% agreed. The other group, you have, you have something to say about
Pretty much the same scenario. Just we just didn't make it.
I see.
Mistake.
We didn't have
problems.
Very realistic. Also, we tried to do the simple voting, and it came out more with voting. We put the worst results
Yes.
were.
Cool. Thank you, guys. Maybe the group over there.
I'll just help you to get to the
I
last.
mean, I don't know what to say. Like, it wasn't too hard.
Don't worry.
Basically, yeah, like we did step by step and functions, and basically, surprisingly, we didn't make any mistakes. Like once we type it in, it worked.
See?
Yeah.
Nice.
We use like query expressions. You know, and our solution really short and nice and readable.
I want to see it.
Yeah.
Any bad surprises?
No.
Cool. Well, thank you, guys. How about the group over there?
Yeah. Well, we formed 3 groups, subgroups. One was just doing random stuff on his laptop with our provider and hanging around. Then we had we can ask the representatives of the subgroup. I think you can say about your experience because you're like seeing F# for the first time.
Yeah.
So I think that's interesting.
What language do you come from?
I'm more of a C++ type of guy, but
And were there like good and bad surprises?
it's just learning, syntax and what goes along with that. Very interesting language, very expressive. Not too much more to add. I was just trying to, wing it without, quite frankly, without reading the script you had there, just kind of doing it on my own.
You must have missed all the template errors from the compiler. Made it hard.
That's nasty.
I think also the fact that you asked if we could stay until 8:45 is probably a good sign that it was fun to write.
Yeah, and the other subgroup, I think we were pretty much almost there. We have the sort of distance calculation and prediction function. Well, we
It's
had
all
that
built
sorted.
for
Yeah.
Nice.
I think you just need to use C++, but you can probably finish it in front of the others.
Yeah. Or at the bar with the beer. Thank you, guys.
Thank you.
Yeah. Thank you, guys.
We
I
got
should
through.
point out to start with Rick's cheating because he programs F# every day and does machine learning every day.
I guess, yeah, that's kind of cheating, but I like tried to go, slow and, ask for input, but yeah. So we got through it pretty quickly, no problems, like the initial setup, and then we generalized to k nearest neighbors and tried lots of versions of k, and it seemed like the more samples we used, the worse it did. So we went and we downloaded the actual Kaggle training set.
Oh, nice.
And it still did really bad. So we tried a horizontal blurring.
That's still like 92% or something.
Yeah, it was better than I get at work. Well, most of the time you don't, get such clean data. And then we did horizontal blurring, and that just didn't really help, but it was kind of a last-ditch thing.
Okay, can you explain the idea maybe for others on the blurring?
So one thing that I know works, if you do it like sort of large scales, if you take sort of averages around the pixel, because a lot of times when they deform to the edges, which is probably what the data set has already done, like they took it and then they resized the image, rescaled it to be flat against the edges of the pixel, and so that causes all kinds of problems with things that like have parts sticking out, like like a 1 with a down part, and everything can be moved around sort of unexpectedly, and so if you take averages, it kind of eliminates the error or helps fix up the error from lots of those little problems.
That can also help maybe if you have, because if you think about it, if you had the same image shifted by 1 pixel, you would have a big problem with the distance, and that type of drawing could help too, like if you do averages.
Yeah, definitely. And so the ideal would be to do averaging all around it, but we were lazy, so we just did neighbors, the left and right, but it didn't really help.
Including to the right on the next line over to the left.
That's true. Things like that.
Any other comments from the other people from the group? Okay.
Fun times.
Cool. Thank you guys.
I can actually report on my, because I played with it on Tuesday, slide hack. I did a version that took all the samples in the training data set and basically averaged, for every digit, it averaged the pictures. So if you want to see it, I can show it.
Maybe let's let the last group talk and then let's do that.
Oh, yeah.
So, who wants to speak for the last group?
Okay, ours was pretty straightforward. Actually, I looked at it yesterday, and we just took the minimum, and then Adam, with that we got 94.2 accuracy, 94.4 accurate, and then Adam looked at the classifier and the distance algorithm, and
yeah, the majority vote decreased the accuracy, and then
the distance algorithm,
we
transforming
changed
it to
distance to a cube. We replaced integers with longs, or else it would overflow.
Right.
And then it did improve it to slightly over 95% when it penalized
95.2.
outliers. But then it decreased again if it went to quadratic. I also tried exponential, like 1.5 for the power of the distance. That didn't get anything fixed.
So one of our questions was, if you're around 94, 95, is it going to stay at any point, for depending upon your application? If you get to 90, huh?
You're asking
If you're able to, in some application, if you're getting 94% accuracy, to improve to 95.5 or whatever, is that going to be a big?
Imagine you're the post office and you're looking at zip codes.
Yes.
Yeah.
I need to
I was thinking of in a trading application, if you're 94% accurate versus 95% accurate, it's all. It's gonna be, but it's gonna be a lot.
If you think about this one, is like 94 is great, but like if you have like 5 numbers in the zip code to do, that's actually each of them could be wrong, and so actually the probability to get it wrong is going to go up quite a bit too. So you probably want to squeeze more, right? Because,
right, and depending upon where you're tweaking in the classifier or in the distance algorithm or whatever averaging you're doing, if you're using a different data set next time, it may get worse actually, right?
When
So
they
if you optimize it for this data set, it might not work as well on another one.
When they design zip codes, do they design error correcting in there?
I don't know.
No.
Don't think so. No.
Parity bits.
Parity bits.
They did the UK postal.
Did they really?
Yeah. It's much more complex.
Cool. Thank you guys.
Well, we should do our raffle now, right? Is that everybody?
Before the raffle, is like, if you guys enjoyed what happened tonight, do not hesitate to proclaim your love for F-sharp on Twitter with the hashtag F-sharp and maybe Tagoku. Just saying.
So for every.
So before we do this, does anyone else want to put their thing in?
Five things which are.
You can't spell them again. It's against the rules.
Business card is just that. Okay.
Yeah.
All right, my bad.
This won't count the business card.
Sorry.
You're already going.
Yeah, disqualified.
Doing so.
Yes, you have to be here. All right, Mathias, you're going to do the grand honors.
The winner is
Yes. Yeah. Your selector.
Jose Coelho.
Yeah.
Coelho?
Yeah.
Yeah.